I'm calling on everyone that's ready to explore rational expressions. Hey everyone, my name's Miguel, also known as the Vegan Math Guy, and you are at Pre-Calculus Summit at Sokotoa Park. And I know somewhere out there we are ready to add, subtract, multiply, and divide rational expressions. There's a few secrets to these things and I'm about to explore those with you today. So if you're ready, let's get started. Whether you're a working professional, college student, or high school student, Microsoft is and will always be an essential tool. CAT, aka Miss Excel, is here to make software like these fun and easy to empower you at work and save tons of time. Since launching Miss Excel in June 2020, she has grown a community of over 1 million people on TikTok and on Instagram through viral Excel trick videos infused with creativity, music, and dance. Kat was recently awarded the Microsoft MVP Award and has been featured in Business Insider, CNBC, and Entrepreneur Magazine as a pioneer in the Excel influencer space. Kat was also named one of the top influencers of 2021 by Forbes magazine. And now you can buy her courses and automate tasks to save time and energy, become more marketable for a job or promotion, and show up powerfully and confidently at work or at school. Join the 16,000 students who've achieved mastery with Kat's courses. And don't forget to use The Vegan Math Guy at checkout for 20% off. That's The Vegan Math Guy at checkout at missexcel.com. All right, welcome back everyone. Just as a reminder, please subscribe to my YouTube channel, subscribe to or follow me on Instagram and TikTok. I am on there and able to answer as many questions as you like. As we're covering these rational expressions, I definitely want to start reviewing multiplying and dividing as the first step, because I think it's just going to kind of, warm us up into how we simplify the rational expressions whenever we're adding or subtracting them. So the very first thing when you have problems like these is you want to, understand, how fractions work. So when we're doing fractions, we're just multiplying them across. However, before we even multiply those together, you want to make sure you factor out as much as you can. Let me tell you what I mean. So let's go ahead and talk about number one. For number one, let's see what we can simplify. That 2x plus 6 can become a 2 times x plus 3. I factored out a 2 from there. The bottom, I can factor out a 5, and this becomes 5 times x plus 2 times the x plus 2. There's not much we can do with that. But on the bottom, that x squared plus 4x plus 3, that can simplify to x plus 3 times x plus 1. So obviously, if you're doing rational expressions, you have to be well versed in your factoring of quadratics and factoring of higher level polynomials. But for the most part, if you know your quadratics, I think you'll be in good hands. So the reason why I did this is because just like when we multiply fractions, we can cross cancel. If you notice, the x plus 3 and the x plus 3 cancel out from the top and the bottom, and then the x plus 2 and the x plus 2 on the top of the bottom also cancel out. So what are we left with? We are left with 2 over 5 times x plus 1. Now, typically, your teacher is going to be totally okay if your answer is left like this. I don't think you have to distribute the 5 into the x and the 1, so we can just leave our answer like this, 2 over 5 times x plus 1. The whole point of simplifying these rational expressions is you gotta just be able to cross cancel. So you want to be able to factor things out and then cancel out whatever you can at the very end. All right, let's go to number 2. So number 2, it's going to be the same step. Now the only difference here is that now we're dividing. So you got to think about what happens whenever we are dividing fractions. We do the keep, switch, flip method. So I'm going to keep the first fraction like it is, but I'm going to go ahead and factor out some stuff. On the top, it looks like I get x minus 4 times x plus 3 over, then I can factor out a 3 times x minus 3. And then, because this is division, I'm going to go ahead and make this a multiplication times, and now I'm going to have a 12 over x minus 4. The reason why it's 12 over x minus 4 is because I flipped or I switched that fraction at the end, because that's how we divide fractions. So we have to be aware of how we divide fractions and also how we can factor these things out. Now look at what cancels out. I have the x minus 4 cancels out. So I'm going to be left with 12 times x plus 3 over 3 times x minus 3. Be very careful, because I think a lot of students would definitely want to cancel out that x plus 3 and the x minus 3 on the bottom, but that can't happen. However, we could simplify the 12 and the 3. Just think of it like a fraction. 12 over 3 is the same thing as 12 divided by 3, so that's 4. So that leaves us with an answer of 4x plus 3 over x minus 3. And that is our answer. So whenever we're dividing rational expressions, you have to make sure that you understand that we need to do the keep, switch, flip method because we're dividing them, and we need to be able to factor these things out. All right, let's go ahead and do number 3. So number 3, it looks like it's another division problem. I'm going to utilize the same method. I am going to go ahead and factor out that first value, the x squared minus 5x plus 4. That looks like it could be x minus 4 times x minus 1. I keep saying you have to be well versed in factoring these quadratics. Over x squared, and because this is a division, I'm going to multiply this and then switch the fraction, so x over x minus 1. Didn't have to do anything to that. All right, now we can go ahead and cancel out the x minus 1s, and I'm not going to show it yet, but this is going to be x times x minus 4 over x squared. Now, a lot of people would say, okay, we are completely done here. However, if you notice, we have an x on top and we have an x squared on the bottom. So the x can cancel out, and then one of the x's on the bottom can cancel out as well. And that leaves me with x minus 4 over x. And that is my answer. Okay, cool. There you have it. Let's go to number 4. So number 4, now we're just multiplying things out. So before I start multiplying this, I'm just going to go ahead and factor out what I can. So I have a 6 on top. On the bottom, x squared plus 9x plus 20. That's going to become x plus 4 times x plus 5 times, then factor out an 8. 8 times x plus 5. And on the bottom, let's factor out a 6. 6 times x minus 2. So let's look at what cancels out. The only thing that really cancels out is the x plus 5. And then we have the x plus 5. And oh, what do you know? We can also factor out, or not factor out, but cancel out the 6 there. All right, so then that leaves us with 8 over x plus 4 times x minus 2. And that's our answer there. There you have it. Great. Let's try another one. Let's go to number 5. Let me go ahead and maybe I'm going to scroll this up. So now we're doing number 5. So that value, then now it's on the top left. So same thing. Let's go ahead and factor out what we can. I can factor out a 5 from the top, and that becomes x minus 3 over 4x squared times x cubed over 6x minus 18. All right. Oh, actually, I left it at 6x minus 18, but I can really factor out a 6 from that. So that'd be 6 times x minus 3. My apologies. Had I not done that, I would not have seen that the x minus 3's cancel out. So that leaves me with x minus 3. X minus 3 goes away. What else goes away? We have an x cubed on top and an x squared on the bottom. So the x squared can go away, and the x cubed would just become an x. And now that leaves me with 5x over 4 times 6, which is just going to be 24. It's kind of an interesting rational expression there, but that is what the answer is. Okay, let's do 2 more of these, or perhaps maybe we can do 3 more here. I'm going to go ahead and do number 7. So let's look at that. Go ahead and see if you can try to pause the video and solve it on your own. Now we have a division problem, so I already know that I'm going to go ahead and do the keep, switch, flip method. So on the top, it looks like it becomes x plus 8 times x minus 3 over, I can factor out a 2 from the bottom, 2 times x plus 1. Because this is division, I'm going to make it times, and then I'm going to flip this fraction. So this is going to become x minus 9, x plus 1 over, and now let's go ahead and factor out a 3 from that, 3x plus 24. So 3 times x plus 8. Very cool. So let's look at what cancels out. The x plus 8, the x plus 8, the x plus 1, the x plus 1. And that looks like it's our answer now. And this is what I keep mentioning. Let's just go ahead and leave it factored out. It becomes x minus 3, x minus 9, all over 6. And that is our answer there. Okay, cool. You know, number 8 is a little too easy for us, so let's just go ahead and do number 9. Okay, we're going to go ahead and go to the bottom left, and let's go ahead and do that value there. So let's look at what cancels out. Nothing happens to the 4x, so I'm just going to leave that like it is. On the bottom, I believe I can factor out an 8, so 8 times x plus 1 times, and now let's look at what we can factor out, or how we can rewrite that quadratic. X squared plus 8x plus 7. X plus 7 times x plus 1 over 8x cubed. Okay, so what cancels out? X plus 1's cancel out, x plus 1's cancel out. Let's go ahead and factor out or cancel out some of the x's here. An x can cancel out on top, and then one of the x's on the bottom right can cancel out, and that's just going to become x squared. And so right now, just right now, we have 4 times x plus 7 over 64. And you'll think you're done, but there's one more that we can do, or one more thing that we can do here. We can go ahead and divide the top and the bottom by 4. That will make the 4 a 1, and the 64 will become a 16. And now we're left with x plus 7 over 16. And there you have it. All right, so now let's go to number 10. Number 10, another multiplication problem. So we're going to do the same method here. We're going to go ahead and factor out a 6 from the top, and that becomes x minus 2 over, and let's go ahead and factor out an x squared. Let's factor out that x squared minus 9x plus 18. That'll become x minus 6 times x minus 3 times, let's factor out a 7 from the top, x minus 3 over 5 times x minus 2. I factor out a 2 there. Great. So then now we can go ahead and factor or cancel out an x minus 2. It looks like x minus 3's go away. We just continue to cross cancel here. And what are we left with? We are left with 6 times 7 on the top. That becomes 42 over 5 times x minus 6. Okay. Now just keep in mind, the secret to this entire thing is simply to make sure that we know how to cross cancel, we know how fractions work, and we know how to factor. And I think that's the secret to all these types of problems. Whenever you're doing rational expressions, you have to be able to factor, and then you have to be able to clearly understand how fractions work. So keep that in mind as we go on to the next step. This is where we're going to go ahead and add or subtract rational expressions. So let's very briefly talk about something like number 1, okay? We're not multiplying anymore. We are not dividing. We're just adding here. So think about what we did when you were doing fractions in 6th grade, 7th grade, perhaps even 8th grade. What were we doing? Whenever we add fractions, we have to make sure that we have a common denominator. In this case, we definitely do. We have both a 15x on the first fraction and a 15x as a denominator in the second fraction. So very clearly, because they have the same common denominator, we can just add across. So this will be 9 plus 2 over 15x, or 11 over 15x. This is pretty simple. If you look at all the problems that I have on the screen, all of them have the same common denominator, which is great. So this is kind of like a good lead up to what we are about to do. So for example, if I just show you number 3, looks like they have the same common denominator, so we can easily go ahead and just add across. 4x plus 7 over 2x plus 3. Very, very simple. Again, because they have common denominators, there's no real issue here. We can just add the values across. But this is where the tricky part in pre-calculus, or if you're in algebra 2, these are the types of problems that you are going to see. What happens when they don't have common denominators? Let's go ahead and scroll down, and I'm going to show you some examples here. And let's just start off with something very simple. So how about number 1? Do you see a common denominator there? Not quite. We have an 8 as the first denominator, and then we have an 8x on the other denominator. And the idea is we want to have the same denominator for both fractions. So the only thing I need to do here, which is quite simple, is On the first fraction, I need to multiply an x to the top and an x to the bottom. Now, what does that look like? This is 5x over 8x minus 3 over 8x. Nice, very simple here. They have common denominators, so we can just go ahead and add the values across. So that becomes 5x minus 3. And there's nothing else to do but just say this is our answer. Then again, they kind of start leading us in to these types of problems. So let's do an easier one. Let's go ahead and talk about number 2. Now, number 2, it looks like they don't have common denominators. But this is why I said that I wanted to do multiplication and division first, because whenever we're adding or subtracting these rational expressions, we want to make sure that we first can factor out the denominators as much as we can, because that's going to help us visualize what type of common denominator we need. So for the first fraction, it looks like I can factor out a 4, and that'll give us 4 times x plus 3 plus 7 over x plus 3. Look at that. We can actually visualize there what kind of denominators each fraction has. The first one just has an x plus 3. The other one, or the one on the left, has a 4 times x plus 3. So we need to make sure that they have common denominators. So I'm going to go to the second fraction and multiply both the top and the bottom by 4. Now, what would that give us? I have 2 over 4 times x plus 3 plus 28 over 4 times x plus 3. And that's the goal. Because look at that. Now we have common denominators. Now we have accomplished what we needed to do with fractions, get common denominators, and now we can just add across. So we can go ahead and add the 2 and the 28 with that denominator 4 times x plus 3. And that gives me 30 over 4 times x plus 3. And of course, I can kind of simplify that there because it's 30 on top, 4 on the bottom. I can technically divide everything by 2. So that gives me a 15 on the top and the 2 on the bottom. Just going to kind of put my answer up above here. And that's going to be 15 over 2 times x plus 3. And like I mentioned, whenever we're multiplying or dividing these rational expressions, we don't really need to simplify it any further. Whenever we get our answer at the end, I really don't think that you need to multiply the 2 to the x and the 3. You don't need to distribute it. Some teachers might be a little picky about it, but to be honest, I don't think it's that big of a deal. The important part here is that you found your common denominators and you were able to successfully combine these fractions by doing so. Awesome. Okay, let's go ahead and talk about something that's maybe a little more difficult in my opinion. I'm going to go ahead and highlight this. We're going to work on number 6. Let's take a look at that as I highlight this. Just look at what happens. A little tricky. One fraction has an x minus 3. The other fraction has an x plus 7. This is where we have to get a little more creative here. And to the first fraction, I'm going to go ahead and add an x plus 7 to the top and multiply an x plus 7 to the bottom. And I'm going to do the x minus 3 to the top and bottom for the second fraction. Now, why do I do that? Well, let's look at what happens. The first fraction becomes 2 times x plus 7. I'm just trying to show all of our work here. Times x, or over x plus 7 times x minus 3. Minus x minus 3 over x plus 7, x minus 3. We've successfully shown here that they have the same denominator now. We have multiplied both fractions successfully, or we have changed them a little bit so that we can have that same denominator, which is what we do now. And I'm going to tell you one thing you got to be very, very worried about. I'm going to first simplify our values here. Our numerator, this is going to become 2x plus 14 over x plus 7 times x minus 3. And the other one, we have to be very careful with this. I'm going to keep it as a parentheses. And this happens every single time that we are subtracting these things. The reason being is because now that when I'm going to combine these things, I'm going to have to do this. 2x plus 4 minus, and I'm still going to have that parentheses because I need to make sure to distribute that parentheses to both the x and the minus 3. So whenever you have a subtraction, you got to be very, very cautious with your work here. And that leaves me with an answer of 2x plus 4 minus x plus 3 over x plus 7 over times x minus 3. and then I can go ahead and combine common denominators. Guys, I'm so sorry that I'm like kind of going sideways here, but I'm definitely running out of space here. I apologize. So I have the 2x minus the x that just combines to an x, and then the 4 and the 3, and that leaves me with x plus 7 over x plus 7 times x minus 3. Ho ho, look at that. The x plus 7s was not expecting to cancel out. And that happens sometimes, but this is why it's important to just leave your denominator factored out, because there is a possibility that something can cancel out at the end. So at the end, I've just left with 1 over x minus 3, and that is my answer whenever we combine these. Relatively simple, it looks like, but of course, as we continue to find the common denominators, it could definitely get a tiny bit confusing. All right, cool. Let's go ahead and do some more problems. I'm skipping through the pages here because I definitely want to show some addition and subtraction. Some become a little more difficult. Oh, looks like oh yes, I know. They all have just common denominators here. Yeah, we need something a little more difficult. I have another page that I can do. All right. I've moved on to a page here that's actually owned and written by Mr. Tyler Wallace. So if you are on TikTok or on Instagram, Wallace STEM is on there as well, and he created these. And I think it's an amazing book that you should definitely think about purchasing. Anytime you're taking college algebra or just beginner algebra, I think his book is incredible. So go to his page. I believe he also has a YouTube channel. But he's definitely on TikTok and on Instagram. His name is Tyler Wallace, aka Wallace STEM. Highly suggest you pick up his book to play along with it. Okay, before I even do this, I just kind of want to do a few problems. Let's just focus on number 27. So I'm actually going to write this one down. It's going to be a little tricky. Okay, so the page that we were doing, it doesn't really have enough space for me to write all my work, so I kind of just went on this blackboard here, but I have the problem that I wanted to work on. This looks a little more complicated. Why? Because the bottom has these quadratics that we still need to find a common denominator, but I don't want to get crazy and start multiplying these things out to find common denominators. I don't want to do any of that yet. So the secret here is that whenever you have a problem like this and we're adding or subtracting these rational expressions, is you want to simplify or factor out the denominator as much as you can. I think I've mentioned that before, so let's go ahead and do that now. The top, I'm just going to leave it as x, and what does the bottom become? It looks like it can be x plus 8 times x plus 7 minus 7 over x plus 6 times x plus 7. All right, this is exactly what we want to do because you'll notice that both denominators already have an x plus 7, so I don't need to introduce that anymore. Now, one of the fractions has an x plus 6, so I'm just going to have to go ahead and introduce that to the first fraction that I have, x plus 6 on the top, x plus 6 on the bottom. Okay, but also that fraction on the left has an x plus 8. The other fraction doesn't have it. So I'm going to have to go ahead and introduce an x plus 8 to the top and the bottom of the other fraction. So let's just kind of simplify that first. I have x times x plus 6 all over x plus 6 times x plus 8 times x plus 7. A little long, but this is why I keep saying just leave it factored out. Don't try to do anything to the bottom. Leave it like that. Minus, and now that second fraction is 7 times x plus 8 over x plus 6 times x plus 7 times x plus 8. Ooh, sounds like a lot of work, huh? All right, well, let me go ahead and write my work here on the right, and let's look at what we have. If I distribute the x and the x plus 6, I get x squared plus 6x minus, and I'm still going to go ahead and, actually, I'm just going to go ahead and, since I'm combining this, remember when I mentioned if we're subtracting, we have to make sure that we subtract that or we distribute the negative sign to both values in the parentheses. So technically, when I'm distributing the 7, I'm really distributing a negative 7. So this is going to become minus 7x minus 56 all over the same denominator that both fractions now have. Okay, now we can just combine the like terms. It looks like the 6x and the minus 7x can combine. This could become x squared minus x minus 56 all over x plus 6 times x plus 7. And whenever you have a problem like this, you should always, ask yourself whether or not the top can factor out in any way. And this is going to become x, looks like x minus 8 times x plus 7. Whoops, I realized that I'm left with an x plus 8 on top on the denominator as well. I did not write that. And when I continue, so I said this becomes x minus 8 times x plus 7. And what do you know? I'm left with x plus 6 times x plus 7 times x plus 8. And those x plus 7s cancel out. So it's always important to try to simplify your numerator because there is a possibility that something can cancel out. So now I'm left with x minus 8 all over x plus 6 times x plus 8. And that is my answer. Okay. As you can see, these definitely get a bit more difficult whenever we have these quadratics as denominators. So we just have to be well aware on how to factor these things, what to multiply out, because if you multiply a little extra, it can get a tiny bit more difficult. Let's try another one, and then I believe we can call it a day if that's okay with you. So here's the problem that we want to combine. And as I mentioned, you want to make sure that you are simplifying the denominator by factoring out as much as you can. So that first fraction looks like it's just x plus 1 on top. Over, let's factor that out. It looks like this is going to be x minus 7 times x plus 5 plus x plus 6 over x plus 2 times x plus 5. I hope I multiplied that right. Okay, so now we just have to look at, well, what does one fraction have and what does the other not have? It looks like the first fraction doesn't have an x plus 2 because that second fraction does have it. So, it also, both fractions want to be part of the party. So we want to make sure that we include that x plus 2 on that first fraction. But then there's an x minus 7 in the first fraction as a denominator, but there isn't an x minus 7 in the other denominator. So I'm going to have to go ahead and introduce that to the top and the bottom. So that's going to give me my common denominators. Let's look at how that's going to simplify out. I'm left with x plus 2 times x plus 1 all over x plus 2, x minus 7, x plus 5, plus x plus 6, x minus 7 all over x plus 2, x plus 5, x minus 7. Right on. Keep it nice and concise, okay? Show as much work as you can. That way you don't get lost. This is kind of nice. Why? Because it's an addition. So, especially for that second fraction, when I start combining or multiplying the x plus 6 and the x minus 7 out, I don't really have to be aware of that minus sign that was originally in the previous problem when we had a subtraction of rational expressions. Because it's addition, I could almost very freely just start combining these things. So how will my fraction start looking? So I will have x, let's go ahead and multiply the x squared or the x plus 2 times the x plus 1. If I use FOIL, that becomes x squared plus 3x plus 2 all over that fraction or that denominator plus, and let's go ahead and combine the other fraction, that becomes x squared minus 7x minus 42 all over x plus 2, x minus 7, x plus 5. Awesome. And again, now because they have common denominators, I can just start combining these things, and it's an addition, so I don't really have to worry about, being conscious of that minus sign if this was a subtraction. So let's see. The x squareds can combine. That becomes 2x squared. The 3x and the minus 7 can combine. That becomes negative 4x. And then the 2 and the negative 42 can combine and give negative 40 over x plus 2, x minus 7, x plus 5. All right. And as I mentioned, always be aware of whether or not you can actually combine or cancel anything out from the top and the bottom. So I'm just going to try to factor out my numerator. It looks like I can factor out a GCF to make it x squared minus 2x minus 20 over x plus 2 times x minus 7 times x plus 5. And I don't believe that x squared minus 2x minus 20 can factor out into anything, because I can't think of two numbers that multiply to negative 20 and add to negative 2. So I'm going to leave it like that. This is my answer. All right, there you have it. That is how you add, and that is how you subtract, that is how you multiply, and that is how you divide rational expressions. So if you have any questions or any comments, please feel free to comment in the video below. Of course, if you want me to review anything else, also let me know in the comments. Please, 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 if you like what I'm doing and if you want me to continue putting more math content out for you, subscribe to my YouTube channel. Please follow me on Instagram and on TikTok. And of course, this is where I leave you. Happy trails.